Hello, my name's Liam Quinn and I'm an independent consultant with Delightful Computing. Thank you for inviting me to speak here. I'm sorry I couldn't be with you today, so I've recorded this. I'll try and be online, but no promises. We don't know if it's going to be possible. That means I can't see the audience. I can't see you all cheering wildly or falling asleep. And so I'm going to try and aim this little talk at both experienced people and not experienced people. So if you find a bit that makes no sense, gloss over it. If you find a bit that's really simple, maybe there'll be a harder bit later. Who knows? All right. What I'm going to talk about is some experiences from one particular XQuery project that I did recently. Data to Type, who may well be in this room, I don't know. Hello if you are. They had a client needing a program to show the differences between two XML documents, and they asked if I could help. So of course I said yes, looking for work and all that, independent. And my background includes the fact I was in the W3C XQuery working group, or XML query working group, for over 15 years. Good heavens. And I've done a lot of XQuery and XSLT, as you can guess. So the problem with this project, the main part that I worked on was a thing called a matcher, and we've got a separate talk about that in XML Prague. The purpose of the matcher is to mark corresponding nodes in two input documents to match them up. Sometimes the nodes will have different content because they've been changed. Sometimes one will be an insertion or a deletion, so it's not necessarily one-to-one correspondence. The client was already using BaseX for the project, so that was actually a given in this case. Now, two worlds, because we've got a program that people will use, and we want users to be able to specify which kind of matching functions they will use at runtime. These then get run in a pipeline in the query in the order that they're specified by the user. You can have some of them run more than once if you like. So the approach is to have a map that has as keys the names of matchers, and then as values a map containing a function item and a description. Now, and this could be built from a configuration file. I'll show you one. Let's see if this makes sense. So here's an example. I called it registration because all the matchers are registered in the matcher framework that runs them. So here we have a variable called matcher definitions. Here I've been lazy and called it a map star, and I'm going to come back to that in a minute. But what it contains, what it is a map, and we can maybe see that here if my mouse pointer's working in the video. And here I've shown the first two entries, and it carries on long below the screen. Find pairs is a map, and its matcher function is find pairs #3. That's a function item referring to a function with 3 arguments, and the M: prefix identifies it as being in the matcher namespace. Not all matchers are in that namespace, but the default ones that come with the program mostly are. Could be anything though. And the about finds paragraphs with identical content. That's there so that a user can get a list of all the matchers with their name, matcher, with their name find pairs, or ID as appropriate, so that in red on this slide for those who can see that, and the descriptions. Okay, so it's kind of like a running with a help. And it's also super useful when you're developing to have little descriptions like that to remind you of what you're intending to have something do. It's not always what it does, right? Okay, here's a gratuitous tree diagram from Paracelsus, kind of Renaissance astrology. All right. The processing of this program is a blackboard model. This is something that goes back to the 1980s and expert systems. So we used a map as the blackboard. The map represents knowledge gained so far, if you like, about which nodes in one document correspond to which nodes in the other document. And I wrote an API, or we jointly wrote it. I think I wrote most of this part. It's a tiny part of the whole application, though. An API provides access, in this case, to components inside that map, which means that the map can be changed, and also there's a central place for monitoring and tracing things. And each of those matcher functions in that pipeline adds matches to this kind of global blackboard map as it goes, returning an updated map. So as it gets more and more matches in it, eventually it will have correspondences between every node in the two documents. And we called it the match box because it's a box containing matches. Oh, okay. Some specific things that I learned trying to do this and that I thought about. One of them is that we're building up a map, as I said, and we could do that. For example, the ID matcher needs to make a map of IDs versus nodes internally as part of its part of what it does. I'll talk about that on Saturday a bit. So we could build up a map by taking a sequence of every child element of a node, and for each such sequence we could make a map entry, and the map entry would have the ID as a key and the node as a value. This gives us a sequence of maps, in fact, with one entry each, despite being called map entry. And we feed all that to map merge. It's a little hard to read, but more importantly, each of these is independent. And in the case of the ID matcher, they are independent, but they're not always. So a different paradigm is to use the fold left function. Fold left takes 3 arguments. It takes a sequence, the same thing here. It takes an initial value, which in our case is an empty map, and a function, which will be called on each item in the sequence. So and each time round, the result of this function will be fed to the next item in the sequence. So using fold left lets us build up a map with access to all the values so far. The fold left function can see the previous results, whereas up here we can't. And for some of the matches that matters. For this particular one it didn't matter, but I wanted a short example. Alright. Nice new thing in XQuery 4, and we were using some of the draft features from XQuery 4 in this project. A nice feature is record types, and a bonus, a plus, a benefit of these is extra type checking, which is great. Minus, as we'll see in a minute, is you can't extend them, which is a recent change, but it makes them less useful for things in an API than they were. Another minus for us was that they're relatively new, so there were bugs. I think they're all ironed out now, though, because the BaseX team is so awesome and fabulous. Sometimes they work. I mean, sometimes it just seems to just take them a few milliseconds to fix bugs. It's amazing, and they never sleep. None of them ever sleep, I'm convinced. But the best thing of all about record types is that named types can give domain level semantics. Let's see an example of what I mean. So here I declare a record called my:\sock, and it's going to be a map, because records are maps, and it contains keys color as color, size as sock size, and extensions is a map. I said before that records are not extensible, but if you put a map in called extensions, then other users can put their own things in there and put in whatever they like because it's an arbitrary map. Whether that's a good thing or a bad thing, I don't know. In every record, in every map that claims to be a sock, it must have color, size and extensions, and they must be the right types. So if I declare a function, my getSockColor, and it takes a sock as arguments, and it returns color and $sock?color. Now I can do that reliably because we know that $sock here is one of these things, a record, and we know that it's got a color in it, and it's color, the right type, so the return value here, color, is correct. And that will often get checked at compile time, particularly with static functions. And I've found I often get error messages if I pass the wrong thing in. If I pass a shoe or a helicopter or a pineapple in instead of a sock, then I get an error at compile time. And it's much easier. An error at compile time is 1,000 times better than an error at runtime. You could ship your program off, you could do lots of test data, and the first day you ship it to a client, they call back and say, on our data we get this error. But with static typing, or with statically typed functions I should say, we don't have full static typing here. But with named typing, we're a step closer to having something that's not likely to do that, so it's great. Even without record types, use types as much as possible. Here's an example. We're going to make the holy hand grenade of Antioch, and we're going to knit it from wool. So if I'm not using a record, then I have to say exactly what's in the map. I'm going to take wool has got a map of strings to integers. I don't know why, but strings to sequences of integers, and it returns a stitch element. And this means that if I try and use my knit grenade function somewhere where we're not expecting a stitch element, of course I get an error. Don't cop out and use node or map star if you could say something more specific. You'll thank yourself later, you really will. Because sometimes things don't go right and you do debugging, or sometimes they're too slow and you do profiling. It turned out that trace output was silently truncated in base X, and I had a function that was producing over 1 gigabyte of trace output, so I thought I was getting it all and was running grep to check whether a particular message came out in the trace, and it didn't. So I said, why isn't this function being called? Why isn't it appearing in the trace? And of course what was happening was it was being called, but the message was after base X had stopped printing trace output. So this has now been fixed, thank you. You either get a warning that it's truncated, or in command line mode it doesn't truncate. How did I get over 1 gigabyte of trace? Well, it prints the object as well as the message. The message function just prints the message, and so that's often better. Returns the empty sequence, but it doesn't get optimized out, at least in base X. There's no easy way in base X to profile time spent in every function. Like, you can't run base X with a special command line option to trace all of the to a time every function. That would be great if you could, but you can't. You can find out the time before and after executing a function, and that can be useful. I put that into our matcher framework. It times each matcher function, and if you've got one that takes a long time, then you know you've got to go and look and figure out if it's doing the right thing. And indeed, using an API, so for every record type, for every map, every different kind of object type, I provided get functions and replace functions. So and create functions where appropriate. So you can fetch something from the matchbox, you can make a new matchbox with a replaced map inside it, and so on. But having the tracing all in one place means it might be called from 50 places, and you don't get a stack trace if there's no fatal error, if it's just tracing. So what I do is I add an extra argument to functions, which is a string, and it identifies the caller or the purpose in those trace messages if I print it. So that's a useful debugging tip. One of the first things I did, we don't have apply templates and modes in XQuery. One of the first things I did was write a module that walks a tree, calling a supplied function for each node. So you give it functions for elements and document nodes and comments and so on. I think I've only ever used element and document node actually. And it builds up the results in a map that you also supply. The module I wrote has a pre-validation function, so you can, if your ignore function returns true on a particular element, it doesn't go down into the element in the subtree. So for example, if we've already identified that a particular chapter, an entire chapter, corresponds to the same chapter in the other document, then subsequent matchers don't need to go down there and look inside it. We in fact don't want them to. And when I did timing, to my surprise, this was often faster than running fold left and recursion directly. Seeing as it uses fold left, I'm not actually sure why, but sometimes timing can be surprising. I mentioned fold left before. Here's 3 ways that you can do this, and I didn't before give the flower version, the number 2 here in this list. For $n in node star, return map entry $n, and then you have to take that through map merge as well as in number 1. The difference between all of these, if you've done anything with XSLT streaming, then you'll be looking at some of these and saying, well, are we making, the first one here is making this huge sequence, but it can be optimized very obviously, and I hope BaseX does that. Similarly, fold left appears to be optimized. It doesn't actually actualize this sequence in memory $node/star here. It uses a generator in some way to make them one at a time as needed. If you have if you have large data, and $node might have 10,000 or 1 million children or 10 million children, it's worth trying these and seeing which one uses most memory. On Linux you can do that with the /bin/time function, for example. I think it's with a -x option, I forget. When you're writing all this stuff, you'll have things like remembering precedence. Don't remember precedence, because if you don't remember precedence beyond very, very simple arithmetic ones, or even there's all these Facebook memes about arithmetic which rely on most people older than the age of 2 not having forgotten their mathematics and arithmetic and which operations come in which order. So here we have exclamation mark map. What's going on here? Is it this? Or is it A into B into C into D? Put the parentheses in there. Use multiple lines, and I'm going to give you an example of that in a minute. That means you can read one line at a time and make sense of it. It also means git diff, if you're using git, will show more useful results. And these extra parentheses, they're free. There's really no charge for them. So here's an example of something I often write. If some expr then open paren stuff, comma, maybe more stuff here, message in this case, which will turn into the empty sequence, and it will just be the same as stuff as a result. Close paren, else open paren, other stuff, close paren. If these things are several levels deep, you should either take separate functions or carefully use layout, but your editor should be able, when your mouse pointer is on this last close parenthesis, it should be highlighting this one after the else, and when you move to the start of this line, for example, the VI % key will take you up here. And so you can add messages very easily, you can add other things in, and maybe this comes from me having done a lot of programming with a programming language that required curly braces for if then else to prevent any ambiguities, but you can get rid of a lot of bugs with if else's that way. We had a lot of maps. We had over 1 million maps being created in one run, for example. Map performance was super important, and thank you, Christian, for improving it, or the BaseX team. I wrote a function to dump a map as XML, which helped with debugging. And there's a little lesson here. Write little tools to help you. And especially if you do something repeatedly, or you're looking at something and you say this would be a lot clearer if. Take the time to do it. It's worth it. Okay. Couldn't get much into a short talk, but here's a summary. One is use the narrowest possible type. This is not a fair type, not a fair summary because it's saying things I didn't say before. But use the narrowest possible type. So don't say map star, say map excess string, excess integer, and you get better type checking. You may get a faster program as well. The optimizer may be able to make use of it. Write little tools like map to XML. And clear code is better than correct code, because if it's not clear you can't fix it. Use descriptive names, use careful layout, use indenting, and it's worth it, because then you can come back and you can fix things. Outline a function in comments before writing it, and then if you haven't fixed it you can go back and fill in the comments later, if you ever remember. I don't always. So, XQuery is awesome. So is BaseX, of course. So are you. Thank you for listening. Go forth and query. All right. Thank you very much. Now, I believe I'm supposed to ask for questions, but I don't know if I'm here or not. That's an existential question. All right. Thanks. And bye.